And on the other hand, we're making sure that the occupants are able to stay out of that dirt that might be in our buildup or the mold that might happen in there that is not coming back into the building. Makes sense, right? Hello, Julia. Good to see you again.
Hello, Daniel. How are you?
Good. Like this time, not in the same room, but last time we were actually together here in the studio, recording together, and that was so much fun, right?
Yeah, it's really good to go live in front of a few people, and then to be together as a different energy. I think that
Definitely.
makes a real difference.
Yeah. That was really was our first time again in front of the camera together.
Mhm.
We had a few hiccups, especially at the beginning, but at the end, just the second session at night was actually pretty good. So if you would like to listen to this, it's like about the Passivhaus designer course and how to get certified and confident. Yeah, because that's often the problem. People say Passivhaus is too complicated, it's too difficult, and do I even get a benefit from it? This recording will really help, and you can find it on, what was it? The Passivhaus weekly article 005, right?
5. Yes,
5.
5.
Yeah. So just go there on the blog on our website. There, article 5, that's where you find it. So if you want to
Exactly.
listen to that, learn about your return of investment, it can be even 7 times the investment you're doing into the course. You can get back with your first project and how your clients can win and all these things that is brought together in that. And if you always want to listen to us, subscribe. Yeah, guys, please subscribe because that's the way to make sure that you're actually listening to us.
Knowledge and all
Exactly.
the good bits,
Yes.
and yeah, interact with us. We're here to also we're here for you. So if you want to interact with us, please reach out. That's also really important to know that we're there. If you have any questions.
Exactly. So what are we talking about today, Julia?
Yeah, today we are talking about airtightness. I would say again, because we've talked about airtightness before, but it seems to be such an important topic and also a topic where there can be a little bit of confusion. So today the topic is actually called airtightness versus ventilation and not a sealed box, because the problem is that there's two ideas that people mix up all the time, and that is airtightness and ventilation, like the title says. You may have heard people saying, I don't want to build airtight. I don't want to live in a sealed box. I'm going to suffocate. How do I breathe in there? And I think that's the misunderstanding that we have to, sort of clarify today, that this is not the case. We need to know what the difference is. Yeah. So airtightness is about the building fabric and ventilation is about fresh air.
Yes. So we build or we design it airtight and then we design our ventilation. It's two different things. They're not the same. It's like, how could we say it? It's like saying, hey, I don't want to build airtight. And that's the reason I'm using a sieve instead of a bucket so that I can get it out again. A bucket is already designed. You can get it out. You just pour it. Yeah. It's not running out itself. Yeah. It's designed for holding the water and then you can pour it out again. You don't need all these holes everywhere. A sieve that is then letting it leak out. So that's the difference, airtightness, ventilation system. But let us clarify that a little bit more. So airtightness is designing this bucket that is not a sieve any longer. So we're designing the building envelope in a way that we're not having accidental ventilation or penetration of air through our buildup, so that we, on one hand, protect the buildups so that our warm air is not going in there, getting cold, condensation, mold growth. We don't want that. And on the other hand, we have the air coming from the outside that is good quality air, is now getting filtered through our buildup, is picking up that mold spores and picking up dust and dirt and fiberglass fibers and then pushing them back into our house. We don't want that either. So we don't want to have accidental ventilation through the dirty, dusty construction setting buildups where the air is then leaking through and you don't even know what is in there. You could have toxins in there because of timber treatments or material treatments. You could have foam in there that has off-gassing. Like if you're using a PU foam, the PU foam itself only works better than air because there is no air in the foam. There is actually a gas in there, and that gas is gassing over time. That's the reason you always have as well that metal lining on it. And we don't want necessarily that gas in our occupant space.
No.
And that's the reason we want to stop and separate the indoor environment from this building envelope. And that's what we're using airtightness for. And as well, we don't want to have diffusion through our buildup. That's the reason the airtightness layer is as well our vapor control system and layer, but that's going too far now. We're not going deeper into that.
Yes.
That's another article to explain the difference between water, vapor, and diffusion. It's like, the water, air, and diffusion. That's the 3 levels. But anyway, so that's airtightness. We're making sure that we're protecting our building envelope so that we have a long-lasting building. And on the other hand, we're making sure that the occupants are able to stay out of that dirt that might be in our buildup or the mold that might happen in there that is not coming back into the building. Makes sense, right?
Totally makes sense. So we're saying that the airtightness is there so that we can gain our control back about our air that's coming into the building. So we're not doing uncontrolled, leaky air that's coming in through all the gaps and cracks, but we're gaining control back. So we're also saying, so now that we've built our nice airtight building envelope, we need to get the air in somewhere. And that's where ventilation comes into play. And what does ventilation actually mean? I think we need to explain that as well. So what does it mean to ventilate your building?
So now ventilation means we're actually designing holes in our airtightness layer that we're letting the air in. Yeah, so we're designing it so that we get letting air in, and there's different quality of holes or different levels of quality or of ventilation that we can have. Like a hole in the wall, not a cash machine, like the Irish are saying. Yeah, it's actually a cash losing machine. If you're just putting a hole into your wall and letting the air venting out, yeah, it's actually allowing air to move through a space in our building envelope that we know the air goes through there, and we can control it in this way and clean this area again. So if there is something happening in there, we can clean it, or theoretically put even filters in there, or make sure that the mosquitoes are not coming through. Yeah, putting a mesh on it. So that's a hole in the wall. Then we can go farther, and we can now we could open our windows. We could have vents like our extraction fans in our bathrooms that we're having. All that are options that we have, and we could have them running 24/7, or we could have them running only under use. That is now pretty much what ventilation is. It's a system to actually make sure that the air in the building has high quality. Or how do you see it?
So we
Julia?
can control. Yeah, we can control the airflow. So window is basically also a hole in the wall, but we can open and close it, so we can control when we want the air coming in and when we don't want the air coming in. So I think that's already a good move on from just making it leaking through the gaps and cracks. So, and that's where mechanical ventilation comes into play.
We want to speak now about the difference between, like we call it natural ventilation, but I don't want to use natural ventilation because natural ventilation sounds good, but it is not good. It doesn't work.
Mm-hmm.
Mechanical ventilation, on the other hand, sounds so mechanical, sounds bad. So, but that's the good thing that we want. The ventilation by natural, like by pressure differences between inside and outside caused by nature, we have no control over. Yeah, so you know it yourself. When you have a window open on one side of the house and a window open on the other, or you're opening now a window on the other side of the house, you could have 2 situations. You open it and you have to reorganize your paperwork and everything is flying around. That's the one thing. Or it could be you open it and you stay there. Where's the breeze? There is no breeze. Yeah. So you see already there is a massive difference between the pressure difference that we have between inside and outside, depending on our weather, our climate, our condition between inside and outside. Yeah. And that means if you have always the same hole, the same size of opening, then we don't know what quality we have. Yeah. So example, I slept in Melbourne in an apartment that had a lot of holes in the wall. And there was one night that was all good. CO2 levels didn't go up. And the next night, CO2 levels went up to 1,500. And the difference was the pressure difference between inside and outside. Yeah, so it was actually the temperature inside and outside was more similar. The pressure difference was more similar. And now we didn't have the exchange happening. So this is the reason why we can't rely on the natural pressure difference between inside and outside. We can't rely on natural forces to actually move it from one place to the other because they're not consistent. They're changing. Obviously, you can now put an extremely mechanical system in there with louvers and openings and gates. We see that in the Middle East with these cooling towers and under the building with tunnel systems that they're using. But now you have everywhere these little levers and you have to open it now in this room. Now you have to close it there. It's a lot of human interaction that is required to do it, or a lot of automation that is required to achieve it. So at the end, you have anyway a mechanical system, but the mechanics is a human that you can't rely on, or the mechanics is an automation that is moving this louver. So at the end, we need anyway a mechanical interaction to change something to make sure that the right quantity of air is coming. And now we're coming to the mechanical ventilation system.
Yes,
Yeah.
exactly.
Yeah.
Now we should get into the mechanical ventilation system as Passivhaus is using it and how to get fresh air in. So if you're saying there's the option of moving louvers, but that's not what the mechanical ventilation system does, right? It's operated with a little fan
Okay.
that pushes the air into the building and on the other hand gets it out of the building.
Yes. So there's again, so now we spoke only about opening windows and having holes in the wall that are helping us with ventilation. There's triple vents in windows in Europe and stuff like that. So we don't want to go there. This is only relying on a force that is changing the whole time, so you have not much control over. Yeah,
Yes.
except you're engaging with it the whole time. Now we can put a mechanical force in there, like a fan. Yeah, like a computer fan. Like I must say, my computer with the 7 fans in there, I would say needs more energy to run the 7 fans in my PC than it would actually need to move the air through the whole house for a heat recovery ventilation, like a ventilation unit. And now we can have a one-way system where we actually supply air. So we push air in, we pressurize the building, but now it's leaking through the building if the building is not airtight, or it goes through the windows. But now we have a controlled airflow into the room. We suck it in. Yeah, we suck it into the house. By that, we know where the air is coming in. And now we push it out. If you open the windows or have holes in the wall, we push it out there, or through leaks into the building fabric. That's one way. But like, let's think about the bathroom. What is normally done in the bathroom? It's an extraction fan. We don't want to push that smelly stuff of the bathroom into the whole house. So we are sucking it out. And if the house is now not airtight, then we're sucking all the air through our building envelope, yeah, and push it out because it's not a balanced ventilation system. We have only a one-way direction. And that's the reason why we're sucking it out in the wet areas so that we're not getting the moisture into the room or the smells into the different rooms. So we're sucking it out. And that means we have openings in the other rooms that sucks this air out. One-way system without heat recovery. And with this, we always get the external condition into the house and we are not able to balance the air because we have only one floor. That means we're always pressurizing or depressurizing the different rooms. Yeah, so if you're sucking, it's depressurized. So we're sucking the air through our building up envelope. If you pressurizing it, getting it in, then we're pushing it out of it. If you're pushing it out, then obviously we have not a problem that we would get the stuff from the walls in, but then we're getting the smells of the toilets in particular into the rest of the house. But that's not the ideal idea. So the next would be now a balance system. Yeah, so we are making sure that every room gets the same air in and the same air out. And that's what we're using in a normal balanced ventilation system. That's as well what we're having in a Passivhaus. In Passivhaus, we're going then the next step. That's the heat recovery. But a balanced system just makes sure that the air that is coming in and the air is coming out is balanced. And if this is now an airtight building, then pretty much only the air going through this duct work that we've created for the ventilation system. We don't need an air in, an air out in every single room. Yeah, we can because the ventilation amount is not the same than the conditioning amount. That volume of air that we're moving is so small that the cut underneath the door is enough to actually move it from one place to the other. If you speak about a bathroom where we have this extraction fan running, this can only work when you have a huge hole in your door where you have a vent in there that then can push the air in, or you have like an opening under the door that you can actually look into the bathroom nearly, like you have like 2 inches more or less cut underneath your door that it actually works. So we have now a balanced system, air in, air out, out in the wet areas and the smelly areas, air in where we're spending most of our time, like sitting room, bedroom, theater room, where we're spending a lot of time. We're normally not spending so much time in the bathroom. Okay, sometimes our teenagers do, but we say, get
We
out.
still want to extract from there.
We still want to extract from there, definitely,
Yes.
definitely. That's that. And now we come what Julia said already, the heat recovery ventilation unit.
Yes. Before we do that, can I just clarify something? I think
Mhm.
that might be important because we're saying we're extracting from rooms that have moisture or odor, and that includes the kitchen area as well. And I think one important thing that we should mention here that we should not confuse that with a range hood. So the
Yes,
extraction of the ventilation system is not replacing your range hood. So maybe we need to
yes.
clarify that a little bit.
Yes, there are systems existing that integrate the range hood into the ventilation system. I would highly recommend against that because you're getting now grease into the system. I would highly recommend not to mix ventilation for fresh air with grease from your cooking. I
Yeah.
think when you're
No,
already
not a
hearing
great
these two things together, you know it's no good. Keep them separated. And your range hood is normally, it doesn't have to be, but I normally recommend a range hood with a recircling HUD. So in other
Yes.
words, it goes in there, goes through the carbon filter and comes back into the room. By this, we're keeping as well the heat in the house, what is helpful in the winter, not so helpful in the summer. However, there is a twin flue system already existing. If you want to go for range hoods that are venting to the outside, twin flue means you have one flue, one goes in, one goes out. And that is coming from Japan. So Japan manufactures providing range hoods with a twin flue. Yeah, that's maybe something good to know if you want to know it, and if you want to know where you can find it. The Japanese market has that. Anything else to mention, Julia?
No, I think that that was it. I just wanted to make
Yeah,
clear that that's not the same thing. I think we can come now to the heat exchanging part
the
because you've explained exactly. You've explained so nicely how it all works, how natural ventilation is important, how we need to make sure that we're not relying on the natural forces, but that we need a mechanical force and where to get it in and out. But now we would still have that problem that the air that's coming in has the outdoor condition. If we open our windows on a day where the outside is not in favor of our indoor condition, like let's say it's a very cold day, 0 degrees outside, you would open your window, you would get all that cold air in. On the other hand, if you had a really hot day, 40 degrees, you would also get all that hot air in. And that's a problem because now we're losing all that energy from our building. But we are now putting something in that's called the heat exchanger, and that changes a lot. So that's the, as Daniel said, the magic.
magic.
And
Yeah.
we need to explain that a little bit.
Yeah, so I'm calling it the magic because there's only a few people, like really a few people that understand what is really happening there. Yeah,
Yeah.
it's not easy to explain. It's not easy to put into words, but the physics are really clear. The physics are super, super simple, but it's difficult
Yeah.
to understand why it works and how it works. By the end, we are just using the magic of physics, how it works. But the simplest way of 50% heat recovery is you take a 100-degree liquid water 10-liter bucket and a 0-degree 10-liter bucket that is liquid. Both are liquid, not gas or ice. That's the reason I'm putting liquid into my wording. And now you put them into a 20-liter bucket, put them in there, 100 plus 0. The average is 50. That means now we have 50 degrees in there. Yeah, 20 liters of that. And if we now fill them back into our different 10-liter buckets, then we have 50 degrees here and 50 degrees here. And by that, we have a 50% recovery. The 100 degrees went down by 50 degrees and the 0 degree went up to 50 degrees. And that's the 50% heat recovery. So we're already needing, if you now want to get that 0 degree bucket to 100 degree, we don't need to get it to 100 degree any longer. We need to get it from 50 degrees to 100. Yeah, and if you get the 100-degree bucket that is already down at 50 degrees, we only need 50 degrees to bring it down because we put them together and then separated them again. And that's pretty much what the heat recovery ventilation unit is doing. We have two airflows that are passing each other with a really thin heat exchanger between them. And in that time that they're passing, the heat is getting exchanged. And this is the reason we can actually not just achieve a 50% heat recovery, we can actually achieve a 95 or even 96% heat recovery now. And this means that we can maintain the indoor condition indoor and the outdoor condition outdoor.
Yeah.
Yeah.
So maybe we need to clarify a few more things. It's getting a little bit into detail now, but I think it's important. One thing is, why would the heat want to exchange? Maybe we need to explain that physical principle that things want to come into an equilibrium.
Yes.
That's the physical principle behind that, because air that's warm and air that's cold always want to make sure that they're at the same
makes sense.
temperature in the end.
Yeah.
And maybe you want to explain, because you said we have a heat exchanger in between. Okay.
So
right.
because we have another article directly after this one, where we go
Yes,
into
that's
ERV and
correct.
HRV. Yeah. And there we can actually go into
Let's do it there.
that in
Good
more
idea.
detail, because this is now already explaining why airtightness and ventilation. We separated that, and we already
Yes.
spoke about the heat exchanger, but the heat exchanger is far more like it's technology that we need to explain a bit more. And that's the reason it makes sense to actually wait another week. Or if it's already online, maybe on our blog, you might be able to find it there already.
Yeah. Right.
And go there. So I think that's the way to go, right?
Yeah, absolutely. So I think great point. So if you're really interested in the nitty-gritties, jump to the next article. That's where we will go a lot deeper into how this all works in the detail. Good. Then I think maybe we just need to make clear. So we need to build airtight and we need to ventilate the building, right? We need to do both for a building to work well.
Yes. So airtightness is making sure that the building fabric is secured from air that is moving moisture into the structure, so that is not happening, and making sure that the occupants are safe from air moving through the structure and picking up not so nice things that would come into the occupant space. That's the airtightness. And ventilation is then what we are designing to make sure that the occupants get enough air. So that's the difference. And now if you want to know heat recovery, energy recovery, what that actually is and how that actually works, next week is the one that we are then talking about that in more details.
Yes, exactly. Good. So maybe just finish it up with the things that you get out of doing this, building airtight, ventilating right. We've got a few advantages, a few things that I think Daniel already mentioned most of them. So we've got a health advantage. So we've got only filtered, controlled, fresh air coming up into our building. We've got our comfort that we will explain next week with the heat recovery, consistent temperature in our buildings. Daniel explained the durability factor, that we don't have condensation in our walls through that accidental ventilation. And at the bottom line, build airtight and ventilate right.
The economics, you forgot the economics, because you
Yes, the
don't have to
economics.
spend so much money on actually
Perfect.
conditioning the external temperature.
Absolutely.
Yeah.
Absolutely.
So thank you, everybody. If you want to have more of this, subscribe, click on the link below or above or wherever it is, or make a note. We are normally releasing this every single week. And yeah, keep following us and let us know what you want to know. Send us messages in, then we can actually gauge the upcoming articles and coffee talks. See you then.
Exactly. See you next week.